Okay, the third video continues on our review packet. Let's see. So number 7. Okay, we got the idea of explain here. So the work that we're going to do to get parallel is we're going to try to see what the slopes are. So we're going to have to take this equation and we'll put it into y equals mx plus b form. Okay, so what we'll do first is add 8x to both sides. This is one way to go. Be careful here. This continues to be negative y, and then 8x minus 7. Sorry, that's positive 8x. And then we're going to divide everything by negative 1. This is one way to go. Multiply by negative 1. That works as well. And so it's negative 8x plus, what did I say there? Negative 8x plus 7. All right. Now the other equation already is in y equals mx plus b form. Wait a minute. Okay. Determine if the lines are parallel. Well, they're not. Okay. So let's call this line 1 and line 2. All right. So what we're going to do is we're going to say line 1 is not parallel to line 2. And here's going to be y. The slope of line 1 is negative 8, and the slope of line 2 is positive 8. So last, when lines have slopes, that are not equal, the lines will not be parallel. Eventually they'll run into each other. Okay? So that's basically what we're looking at. All right, a line is perpendicular to a line whose equation is y equals x over 3 minus 2 and passes through this point. So let's start with this. This is a great idea to highlight keywords. So we've got a line perpendicular to y equals x over 3 minus 2. I'm going to change that right now. X over 3 minus 2 is equivalent to 1/3 x minus 2. Okay? Slope of this line is 1/3. Now, a perpendicular line, use that symbol for perpendicular, must have a slope that is the negative reciprocal. So basically you're going to multiply it by a negative and then flip it. So the perpendicular line, m, is going to be negative 3 over 1. Okay? Now we'll go over here and we'll write the equation using this, this point right here. I use point slope whenever I can, or the graph. Could have graphed this as well and try to run into the y-intercept, but this is just more efficient. So if this is x1, right, and that's y1, we can sub in 2 right there, and then the slope we're going to fill in is negative 3 over 1, x, and then minus sub in 6. Okay, we can leave it like this. That is a valid equation for a line. All right. Let's see. All right. So, all right, it's given that D is the midpoint. Consider the following diagram and state the conclusion each statement results in. Okay. So if D is the midpoint of AC, okay, means we've got AC. It's going to cut AC, the segment, into two equal segments. So AD is going to equal or be congruent to CD. Now, it doesn't ask us to explain, it just asks us to write the conclusion. Really important idea that we're on right now. So focus on this one quite a bit. Okay, so now we have a segment bisecting, this is tricky, an angle. So what should be produced? Two equal angles. So let's go ahead and let's highlight what angle they're talking about. If I highlight angle ABC, we're talking about that angle right there, the big angle. It is bisected into two equal angles. I'm going to give you two options for this one. Okay, we can say angle 3 is going to be congruent to angle 4, or we could name it with a three-letter path. Okay, angle ABD is going to be congruent to angle CBD. Okay, one that we haven't worked a ton on, but we need, is this perpendicular symbol. So if DB is perpendicular to AC, right, DB is perpendicular, you should throw a right angle in there. Either side, both sides are right angles are produced from perpendicular segments. So what we could do, let's bring this out down here, okay, because it's a little longer of an conclusion. So, all right, the conclusion is that either angle 1 and angle 2 are right angles, or we could say angle ADB and angle, follow the path, right, A to D to B, and angle CDB are right angles. You could say either one. Either use the letter or the numbers, or you could do the three-letter path. All right. Now DB bisects AC. Oh, it's the same as a midpoint. Okay, DB bisects AC. Same thing. So D is the midpoint of AC. I spoke about bisect. I really should have stuck to midpoint. Midpoint finds the middle point, just like bisect cuts it into two equal halves. Okay, so again, the conclusion is going to be the same. AD is congruent to CD. All right, so that's number 9. All right, number 10. So, all right, we're told that G is parallel to H. That's what those arrows mean, is that those two lines are parallel. They told us here as well. Now, an angle 1 happens to be congruent to angle 2. We usually mark it that way. When something's congruent, when you have congruent angles, let me just draw one off to the side here. We try to mark the diagram to keep track of that stuff. So we put an arc in there. That kind of indicates that these two right here, these two are congruent angles. Okay, arcs are for angles. The slashes are for segments. So we'll do that a lot this year. Now, angle 1 is congruent to angle 2 because it's given, right? Now, the fact that these two are parallel also means angle 1 is congruent to angle 3. So here we go. Angle 1, here's what we should do. Angle 1 is congruent to angle 3 because when corresponding, I should say this first. I should say corresponding angles, because corresponding angles are congruent. All right, that's the symbol for congruent, so I'm saying that word, congruent, when parallel lines are cut by a transversal. So that's what this looks like right here. All right, so that's just getting me 1 is the same as 3. That doesn't help me with P parallel to R, but watch this. Now, angle 1 is congruent to angle 2 because they told us, because it is given. Okay, whenever they tell us something, we can use it. All right, it's told to us up here in the instructions. Now, this is where we've got to make a conclusion. If angle 1 is congruent to angle 3, and angle 1 is congruent to angle 2, we can sub in angle 2 anywhere that we say angle 1. So we're going to kind of steal this equation again. We're going to rewrite it, but instead of saying angle 1, we're going to say angle 2 is congruent to angle 3. Okay, and that's by substitution. Okay, and I'll explain why. Angle 2 replaced angle 1 in the first equation. Or actually, congruent statement is what it really is. But we'll be a little relaxed on the writing. Now, this is really tough. Line P is now parallel to line R because when alternate exterior angles, that's what those are. Angle, if you really look, angle 3 and angle 2 are alternate exterior angles. So when alternate exterior angles are congruent, then lines cut by a transversal must be parallel. Now, I don't expect students yet to do all of this, just you've got to explain yourself, okay? So that's kind of what, when you make a statement, when you tell us something, you got to have a reason why, okay? So that's going to be it for this video, and we'll continue with the next one.